All right, good morning, everybody. It is Tuesday, and today you are turning in, I think, assignment 13, which is 621. So that's further down here. Let's see. 621, click on that. Won't let me click on it. Okay, so you're turning that one in. And then today we are doing, having an asynchronous day. So you're gonna work on your own, although I made this video for you today, so you're not really working on your own, you're taking notes. The first thing I'm gonna have you do is take notes on the two methods that we are learning so far. Last class period, we learned the equals values method. So go ahead and take notes on this. So explaining the method that we learned last class period, you're going to take notes on that. And then today we are learning the substitution method. So, sorry, my mouse is not cooperating with me right now. So we're going to, you're going to click on the substitution notes right here. You're going to take notes on this and turn it in by 11:30 for third period, and by before 1 o'clock for fifth period. Okay, so these two pages need to be turned in here on your classwork where it says notes. And then after you do, so that I'll use that to take roll. And then after you do that, you're going to take notes on this video that I'm going to make on 56 through 60, skip 59. And you're going to turn those in for in the bookwork section right here. Okay, so those problems 56 through 60, skip 59, you turn in right here. And then your homework is a worksheet. I don't see it posted here, but I'll make sure it posts. It's going to say A14 homework, and it's a worksheet that is 8 problems plus 3 problems from the book. So that will be due next class period, and just look for the due date on the Google Classroom. All right, let's start this notes on 622 substitution. So I need to go to my Jamboard here, starting with 56. Let's, so actually 55, a couple days ago, we left off with 55 where we solved this problem, and I actually had you do it. I said, okay, let's use equal values. Let's solve this for y. This one's already solved for y equals negative x minus 7. And if we solve this for y, we're gonna get this right here. If I solve that equation for y, I'm gonna get y equals negative 3/5 x minus 13/5, and then I would set it equal to the negative x minus 7 part. And then I add 13/5 to both sides. I multiply by 5 to get rid of this fraction because I don't want that fraction. When I multiply it by 5, I get 2x equals negative 35 plus 15. Then I get x equals negative 11. Plug it into the negative x plus 7 part, and I get 4 for y. So the solution was negative 11, 4. Okay, and that's how you do it equal values. With equal values, we kind of got some messy fractions in there, but not too bad. So let's do it a different way. Let's do it the substitution method way today. And what is the substitution method? So you've taken notes on the substitution method that I just told you to take notes on. And right now we're going to use substitution. So these are our two equations we have, 6-56. And you can write this at the top of your paper, assignment 14, classwork, 56, 57, 58, 60. First equation is y equals, I'm copying from here, negative x minus 7. The second equation is 5y equals, plus 3x plus 3x equals negative 13. Okay, so you see we have these two equations. One of them is going to have a variable that has no number in front, no coefficient. So this has a coefficient of 5, but this only has a coefficient of 1, right? There's an invisible 1 there. So that's the variable we want to solve for. This one is already solved for y. We know that y equals negative x minus 7. So we are going to substitute. We're going to use the substitution method. We're going to substitute what y equals. Y equals negative x minus 7. So you see how they circled this? This is good. This is what y equals. Y equals, I'm going to circle that. and I'm going to substitute it in for the y into the other equation, okay? So you really need to try this. I know students get confused with this, so definitely try a few of them on your own. I have the worksheet for you to try them, so you're going to do that. Okay, so we're going to substitute, instead of y, we're going to put negative x minus 7 into this other equation, the second equation. So we put 5 times negative x minus 7 plus 3x equals negative 13. Okay, and what that does is that has eliminated our y's. Now we only have equations with x's in it. Okay, so now we can solve for x. So we're just going to multiply out, distribute here, the 5 here. 5 times this is going to be negative 5x minus 35 plus 3x equals negative 13. There we go. So now we want to combine like terms. Negative 5x plus 3x, going to combine this one and that one. That gives me negative 2x. And let me go ahead and add the 35 over here and add the 35 over here. So I want to combine those like terms. And 35 minus 13 is 22. Then I'm going to divide by negative 2, and that gives me x equals negative 11. So if we found x, now we need to go back and find y, which is pretty easy because this first equation was solved for y. So y equals negative 11 minus 7, and two negatives make a positive. So 11 minus 7 is 4. So y equals 4. So we always want to write our answer as an ordered pair, xy ordered pair. X goes first. So our solution is negative 11, 4. And that is how you write the solution. Okay, because these are two situations. Remember the pool that's emptying. This pool is emptying at a rate of 1 gallon per second, and it starts out at negative 7 feet, so it's below ground. This pool, when we solve for y, is emptying at negative 3 gallons per second, starting at like 13/5 of a gallon. Okay, so that is how you use the substitution method. Okay, we're going to do a few more problems here. We're going to do 57, so I need to clear this out. This is a video, so you can go back and pause it if you need to see the work. Okay, I need to go to the next slide, 57, and get my pen back. And let's read this. Bharat and Ingrid leave their building at the same time on their bikes and travel in opposite directions. If Bharat's speed is 12 kilometers per hour and Ingrid's speed is 14 kilometers per hour, how long will it take until they're 78 kilometers apart? Okay, two things here. So let's say they're starting at the same point, but they're going in opposite directions. So if Bharat is going this way at 12 kilometers per hour, and then Ingrid is going in the opposite direction at a faster rate. She's going 14 kilometers per hour. Okay, she's going slightly faster. How long will it take until they are 78 meters? We want this to be 78 meters. I'm sorry, kilometers, because they're traveling kilometers per hour. So 78 kilometers. Okay, that's what we're trying to figure out. Well, there's a very important equation that we need to know. Distance equals rate times time. Hopefully you've heard of this equation. This is from science and math, but in science class. So distance equals rate times time. So the distance that something travels is equal to how fast you are going times how long you travel for that distance. So that makes sense. I can go 500 miles if I travel 5 miles per hour at a certain amount of time. Okay, so we're going to use that equation for Bharat's time. Okay, so this is Bharat's time. The distance that he needs to go is so he is going 12 kilometers per hour times some time. some time t, right, is equal to his distance. Okay, and let's say that's 78. So let me cross that out and put 78. Go backwards, 78. So I put the distance over here. Distance equals rate times time. For Ingrid, she is going 14 kilometers. So 14 times her time is, and we want to know how long is it going to take for her to go 70, but really she's not going 78. It's 78 total. Okay, so what we need to do is this. Okay, so we're going to do this problem a little differently. That's not actually going to get us where we need to go. Since they're going in opposite directions, we're going to add those two rates together. 12 t plus 14 t, and we want to know how long is it going to take to make 78 kilometers. Okay, because since we're going in opposite directions, they're getting away from each other faster and faster. Okay, so we add them together and equaling the distance, their total distance that we want. So when we solve this, we only have one variable. So we have 26t equals 78. Divide both sides by 26. So t equals 3 hours. Okay, so it will take them 3 hours to be 78 kilometers apart. Okay, and we didn't use a lot of substitution in this one. We could use substitution in this one, but it's easier since they're going in opposite directions. That's how you handle a problem like that. You add the two speeds together. Okay, a little shortcut there, and then set it equal to the distance that you want them to be when you add them together. All right, so that's 57. I need to go to the next slide. I need to clear this away and go to the next slide, which is now covered by my controls. So let me move the controls away. Okay, 58. When May solved the system of equations below, she got the solution x equals 1, y equals 6. Without solving the system yourself, can you tell her whether the solution is correct? How do you know? Okay, so this is the answer she got, x equals 1, y equals 6. And we want to know if it's correct or not. We don't need to solve this to find out if it's correct. There's an easier way, and that is to check the solutions, right? So go ahead and write 658 on your paper. Go ahead and write x equals 1 and y equals 6. That's our solution. And this, we're going to write this equation 4x plus 3y equals 22. And then I'm going to put the other equation like way down here, x minus 2y equals 0. If I want to check if 1, 6 is a solution, basically that's what she got, right? This is x, this is y. So can't I plug both of those numbers into the equation here and see if I get 22? Okay, so I'm going to put 4 times 1 plus 3 times 6 equals 22. So I just plugged those numbers in. And 4 times 1 is 4, plus 3 times 6 is 18. 4 plus 18 is 22. So it worked. Her solution worked in the first equation, but it also needs to work in the second equation as well. So we need to plug these numbers into the second equation. So 1 minus 2 times 6, does that equal 0? 1 minus 12, does that equal 0? No, that equals negative 11. Negative 11 does not equal 0. This is not true. So since her solution didn't work in the second equation, but it only worked in the first equation, we know this is not a solution. And that is how you can check your work, okay? Because the solution you get has to work in both equations. Okay, since it didn't work in the second one, it's not a solution. It worked in the first one, but it has to work in both of them to be a solution. We didn't have to solve it. We just plugged in the coordinates into both equations to check our work. And that's how you can check your work every time. All right, I need to go to the next slide here, number 60. We're skipping 59. We're on to number 60. Let me get my pen back. Okay, so we're gonna write down 660 here. Another word problem. Carter walked for a while at 3 miles per hour and then continued his journey on a bus traveling 15 miles per hour. His time on the bus was twice as long as his time walking. How long did he ride on the bus if the total distance he covered was 66 miles? Let t equal the time he walked in hours. Okay, so again, we're using distance equals rate times time. When there you see a rate of miles per hour or kilometers per hour, that is your rate, right? That's a speed. Rate is the same thing as speed. They're the same thing. So at first, Carter goes 3 miles per hour because he's walking, right? So 3 miles per hour. But then he takes the bus and he goes faster and longer, and he's going 15 miles per hour on the bus, okay? So this is like how he travels. His time on the bus is twice as long as it is on walking. So the time on the bus, this time, let's see, we'll call one X and one Y. His time on the bus is, let's say X is his time walking. Define our variables here. And Y is his time on the bus. Okay, so it's time on the bus. Y is going to be twice as long as it was walking, so equals 2x. Okay, so if this one is twice as long as this one, you need to multiply this one times 2, right? That's what twice. Whenever you see twice, it means you're going to multiply by 2. So this is our second equation. Okay, the first is our rate is how long does it take to go 60 miles? So he's going 3x, that's his time walking, which is different from his time on the bus. 3x plus 15y is his time on the bus, so y is the time on the bus, is equal to total of 66 miles. Okay, so this is our first equation. This is our second equation. Well, we can use substitution. We can substitute this second equation because it's solved for y already, right? Y equals 2x. So I'm going to circle the right-hand side. I'm going to plug that in for the y over here. Okay, so the 2x is going to get substituted for the y. Okay, because y equals 2x. So I'm going to substitute 2x here. So we have 3x plus 15 times 2x equals 66. Now we just have one equation with x's, not an x and a y, because whenever you have two variables, you need two equations to solve this. Two unknowns. You have two unknowns or two variables. You need two equations to solve it. Well, we have two equations. We have this one, and we're going to plug this one into this one to solve it. So we have 3x plus 15 times 2 is 30x equals 66. I add these two together because they're like terms. That gives me 33x equals 66. We divide by 33, so x equals 2. So that means he spent 2 hours walking. Okay, let's see how much time he spent on the bus. Well, for the bus, we are going to plug in 2 here. We found x to be 2, so y equals 2 times 2. That equals 4 hours, and it's twice as long as the first one. So 4 hours walking. So we could write this as a word problem. We can he spent 2 hours walking and 4 hours on the bus, right? As a solution, short solution written, we put 2, 4 like that if we define our variables as x and y like that. Okay, so you can see we've used word problems to use substitution here, to use a system of equations to solve our word problem. And we use distance equals rate times time twice in this lesson. So you want to turn these notes into the bookwork section of your Google Classroom. And then move on to the homework. So you want to turn this in for credit for being here today. And then you can work on the homework, the worksheet, and the 3 problems that are assigned. All right, have a good afternoon, guys, and I will see you again next class period.